Okay, so law of sines concerns. What kind of concern could there be about the law of sines? Do you remember we spent some time on a problem where it worked out really strange? It was the problem where I said a fancy word. Do you remember? It was the blank case. Indeterminate. The indeterminate case. All right, let's spend a minute talking about that. I have a few slides in here from Heart Week, which is coming up soon here, but take a look at this example right here. Law of sines concerns. All right, we've talked about this before. Not every set of numbers and angles can make a triangle, okay? So what if they've got this side here, the dotted line side, that is indeterminate, like you can't tell how long it is? Do you get if I make A too small, it won't connect up and make a triangle? And unless you change this angle here, of course, if you lower this angle down, to small enough, it could connect. But assuming you keep that angle fixed, then A, you can either find a length for A that would make it fit just perfect so that it touches straight down, makes a right triangle, that would be the shortest that it could be and still work. Or you could make it slightly longer than that, and then it could be swung either this way or this way. All right? I'd like you to think through, what does this mean? If A is less than B sine A, what in the heck is that talking about? Remember, this is angle A right here. So sine of that angle, if A is less than B sine A, what would be true? Would you have no solutions, as in there is no triangle that would work? Would you have one solution? There's only one triangle that could work, and it's like the perfect right triangle. Or two solutions. If this was true, would you have the scenario where it's just a little too long to fit straight up and down, so you have to kind of put it at an angle this way, or maybe at an angle that way? All right. Hint, I would write a little equation, like sine of theta is equal to blah over blah, and then try to figure out what to do with it. All right? Try to write an equation for this. I'm going to pause for a second. Okay. Now, at this point, I can tell there's some groups that are rocking and other groups that are like, I'm totally lost. So let me make sure that you're on the right track. Would you agree that sine of A must be equal to little a over little b? Sometimes. What do I mean? That doesn't always work. When is that true? That's only true if what? If it's a right triangle. That's only true if it's a right triangle. So then when I solve it, which is what obviously they've done here to get b sine A, they must have put the b on both sides. So you times by b here and times by b here. Do you get that that equation is really only true if it's a right triangle? And therefore, that's this one. And therefore, if it's a right triangle, how many solutions are there for A? Okay, there's only one way you can make a right triangle. You see what I mean? So this one's 1. Figure that one out. Now figure out these two. Figure out what it means if little a is got that sign in there. I'm not going to say it or it'll throw it all off. Okay, so try to figure out what 1 and 3's answers are. The answer for number 2 is you get one answer if this is true. I'm going to pause to let you finish up the answers for 1 and 3. Okay, let's get this part over with. So, what was the answer? What do you guys think? For number 1, do you think that you would have, if this is true, do you think you would have 0 or 2 solutions? 0 solutions is correct. Nice job. Why? Because this side would be too short. A would be too small. It wouldn't touch. Now, if you can't see that, maybe this will make more sense to you. Under this scenario here, A, they throw in all of a sudden just B. Do you see B on the picture? B's up here. Do you get that they're saying that A is smaller than B? Another way to say it is B is bigger than A. That's one of the requirements here. Think about this. If A got bigger than B, it's really, really, really long. And like, I think of it this way. It can be close to B, but if it was equal to B, do you get it wouldn't make a triangle anymore? Unless you swung it way out this way. You see what I'm saying? You couldn't have two options anymore. All right? So if this A length, which obviously is the thing that can be changed, if that gets to be too long, all of a sudden the only way to do it is to run it way out here. And then this dotted line, which can be any length we want it to be, we can still make a triangle. You can still make a triangle with it, but you can't make two triangles. This is the one where you'd get two solutions because your A is big enough to touch. You know, it's got to be whatever this minimum distance is. It's big enough to touch, but in fact, it's a little bit bigger than that. So then you have to swing it either left or right. And you would think unlimited sizes work, but as it gets longer and longer and longer, the triangle that goes this way eventually can't work anymore if it's the same size as B. All right, enough about the indeterminate case. You're going to have this kind of question is the challenging question. It's like, what happens if your triangle can't be a triangle unless you change this to be just the right length? All right, so I'm going to leave this as a, you need to be able to handle it if we make the triangle so that one of the sides can be adjusted. And that one side that can be adjusted, you'll have to figure out like how long you want to adjust it to be to make it work, to give you either one answer or two answers or no answers at all. Do you get that there's a length for this one in this picture? That the A, if you make it too small, it won't touch? Okay. And if we keep this angle fixed, and if we keep this angle fixed, do you get there's really only one length that C could possibly be in this scenario? I mean, because if I extend it out to just that right length, then it's going to touch, and then you can't, if we keep these angles both fixed, if we keep them both fixed, then there's only one possible length for A, and you'd have to figure out what it was. All right, so let's say this is 8, and let's say A is the length we don't know. Let's say this angle is at 100 degrees, and let's say that this angle, what does that feel like to you? Like maybe 30? Goodbye 30. I'd like you to figure out how long A has to be. Don't answer these. Just figure out how long A has to be. I'm going to pause for a second while you figure that out. Okay, so there is two approaches. You could use the law of sines after all, because I didn't realize by giving you those two angles, I was really giving you all three angles, wasn't I? Okay, and so then if I had given you that angle, you have an angle, and let me think about it. What is that? 60? 50? 50, yeah, sorry, 50. And if that's a 50, and I have the side across from it, and I have this as 50, law of sines would work great. But either way, what was A? By using either law of sines or law of cosines, what'd you get? Want to talk about the law of sines? No. Law of cosines, okay. With the law of cosines, A squared plus B squared minus 2AB cosine C equals C squared. If you pick the right, I mean, we know this is true for any triangle, right? So then it's just about picking the right A, B, and C, and then it should work, okay? And we're trying to figure out here is side A. We don't know how long side A is, right? So then we need to strategically pick, if we had all the sides A, B, and C, we would obviously just put them all in there, and we could solve for the angle. But we have plenty of angles. So then the question just becomes, which angle should we pick for C? Which one seems like it should be the right angle for C? And I know this has got labels on it of A, B, and C, but that doesn't mean that we should use this as our C for sure. Get what I'm saying? These could have been R, F, and P. It doesn't matter what letters they started with. I have to change it so I use the right thing for C. Do you see? So, which one should we call C? We don't need to use this as our A, B, and C. Which one should we call C? 100 degrees. Do you get, I just said you don't have to obey the test if it labels it A, B, and C. You can rename them anything you want. So since our formula needs to have the angle in question be the angle across from the side we want this one to be C. And if that's going to be C, then I can put 100 here. And if this is going to be C, I don't know this, right? And then if this is going to be C, then the other ones must be A and B. So let's call this A and this one B. And then B can be 8. And that's 8. And then A, don't know, I'm getting confused here. We don't know this side over here either, do we? Okay. Then we will have to use a combination of law of sines and law of cosines. I tried to morph this problem from what it was originally, which was where this angle is variable. And I tried to think I could just make that into a law of cosines problem, and I didn't. I think I failed. It could have been, the law of cosines can be used, but only if you have only one variable. And we have 2 variables in this one. We had to use the law of sines first. So I apologize. I told you you could use the law of cosines to solve it, and without the law of sines, I don't think you could have. Okay, let's move back to the way the problem was originally supposed to be and see if you can get it this way. If this angle right here can be changed to anything we want, if it's variable, it's flexible, then do you get we could make it really small and we could make A be kind of on the small side? Or we could make A be really long and, you know, have that angle be bigger. All right? Is there any limit to how long A could be? There's no upper limit on it. In other words, A could be ridiculously long, right? I mean, it could go forever that way almost. Okay, so there's really not a limit on the top end of A. Is there a limit on the low side of A? Yeah. So A can't be the same length as B, can it? So it has to be bigger than B. So would you agree that A has to be between, if I was going to write this as a little interval, the lowest that A could be is bigger than B, so it can't be B, but it could go all the way to infinity? Does that make sense to you? It has to be just a little bigger than B, so A must be greater than B. But there's no limit on how big it could be. A could go to infinity. And that other scenario, that other problem I showed you, there was a top end limit and a bottom end limit. Yes? You are correct. This should be a parenthesis right here. Yep, you don't have to re-explain it to me. Yeah. It's from B to infinity. You're right. And it can't be B and it can't be infinity. So, all right. Sorry, I shouldn't have even tried that slide because it wasn't set up the way I wanted it to be. All right. So, what happened here? It's upside down from the way we've done it a lot of times. Do you get that you can do it upside down or right side up and it doesn't matter? Okay, so law of sines, good for, in fact, law of sines is more useful than the law of cosines. But there are a couple scenarios the law of cosines is really handy. And that is if you have all the sides of a triangle and or if you have just the right setup where you just can't make the law of sines work, then the laws of cosines will come in and save the day. All right, I'd like to go to the law of sines and the law of cosines will work for any kind of triangle, including right triangles. Yes. All right, so go to this page, the green one, called Example 1. At first blush, does this appear to be the type of question that we should use law of sines for example 1? No. Would you please use the law of cosines and try to figure out anything? Like, could you figure out another angle? Could you figure out, if we could get one of these angles, that'd be handy. Usually these guys work together. Like, law of cosines can do one part of it, but then the law of sines is much better for doing the other part of it. See what I'm saying? What can the law of cosines do for us? Do you think it's going to help us figure out another angle? Actually, it won't, unless we know all the sides. If we know all the sides, then it can figure out an angle for us. The law of cosines is better finding that third side, like this. So would you find that third side for me? Once we have the third side, then we can use law of sines again. Again, law of cosines and law of sines really work well together. So to start with, use the law of cosines, find that blue squiggle side. Okay, got to unfreeze my board here. So, what do I do? I got to put in A, B, and C, right? So which one's got to be C? Okay, you tell me, you're saying this is C? You're saying that angle across from that has to be our C? Okay. How are you? Tell me what you're thinking. Why do you think that?
Because that's definitely going to be the biggest angle if the other side is 30.
Oh, interesting. So you're thinking that that has to be the biggest angle?
Yeah, because the other angle is 36, and then the other side is less than.
I'll buy that how it looks right now. That looks like it's about a 90, and so, you know, like appearance of the triangle goes. Yeah. Can't trust these things are drawn to scale.
Well, use like the sides.
I don't want you to make the assumption, though, that C's always got to be the biggest side. I know when the a squared, b squared, c squared thing, you know, back when we had right triangles, C, the hypotenuse always had to be the biggest side. Doesn't always have to be the biggest side. Maybe you're not saying, maybe you're not here. I'm not hearing what I think I'm hearing, but I'm not sure that your assumptions are correct on that. All right, so let's see what you got for your answer. Let's see if I got the same answer. So what did you guys get? 9.8. Raise your hand if you had 9.8. Okay. All right. So if that's 9.8, that came from sticking in A, B, and C. So would you tell me, what did you stick in for A, B, and C? What did you make this? You didn't have to pick these, but which way did you do it? Okay, so that's A squared. Is that what you're saying? Got it. Minus 2 times that again, which is 16.7 and 13.5. And then cosine of C is equal to, oh wait, but we know C, don't we? We had to use the angle we knew. And that said something. We had to use the angle we knew. I want you to think about that for a second. That had to be C. That had to be C. If this has to be C, then this one has to be C. Okay, that's why they all got the right answer. Did you get the same answer? Oh, 9.2 or 9.8? Okay. All right. So, what I need you to know this: you only have one angle. That angle has to go in the only spot in the formula that has an angle, right? And that forces that to be C. And if that's C, then the side across from it, this little guy has to be the one that we're solving for. Okay, so when it's all said and done, you put that all in your calculator and you take the square root at the end, you get 9.8. Pretty much everybody got it, and that's cool. Do you get, now that I have all three sides, I could use the law of cosines again because I have A, B, and C, and then I can find any angle I want. But there's a way faster way. So using the law of cosines to find this angle right here, for instance, let's call it theta. Do you get law of sines could be used, and it'll be a lot faster. Okay, cool. All right. I'd like you to do example 2, and you can't use the law of sines because it just won't work. I know in a moment you'll have an angle, and then you can use the law of sines. But for right now, you don't have any angles, so you must use the law of cosines to solve example 2. I'll pause for a second, compare with groups that are near you, and see if you get the same thing. How about we all solve for the same angle? Would that make sense? That'll make it go faster. Which angle do you want to solve for? The one between the 9.8 and the 24.1? How about this one? Is that okay? All right, let's all solve for that one. Find that green angle. That means that in the law of cosines, that has to be a certain letter. All right, I'm going to pause for a second. Let me give that a try.